Hello, everyone. So I'm Dominik Süß, working at Adobe in engineering.
I'm Tom Blackford, working in Adobe Managed Services as a cloud engineer. One of the things that I look after a little bit in Managed Services is assisting our Tiger team for upgrades with any kind of non-standard or notable, more complicated upgrade projects.
OK, so what we will be talking about is not the real deep technical talk, but this is rather about more of a case study on how we try to make sure that the product is working well for our customers, and also making sure that the process that you have during upgrades and deployments in general works pretty well. So, and this is covering the history of how we got where we are today. So that's why this is called When Product Meets the Real World Data, because to get started about the ancient times when we started thinking about this to get closer to what customers really need and what the problems are that all of you probably experience. This required to having AMS being the ones internally pushing on us and saying, OK, yeah, it's nice what you do in terms of lab testing and having these kinds of test setups. What we are seeing with customers and deployments is not matching those scenarios. There's a lot that can be optimized. So back at pre-6.2, most of the testing was about having a lab test, having a Jenkins setup with a huge matrix of certain tests being done. This is still the case. We are still testing under those lab conditions for regression testing. But we didn't actually use product data. The only thing that was happening was that we had Adobe.com always going live with the product, but this is one single project, which is probably not matching the scenarios, all the scenarios that we have out there in the wild. So for one particular case where this hit the road, we had a talk in 2016. Tom will sum up a bit of that.
Hi, everyone. So those of you who are here in 2016 or in the old location might remember I did a talk about a particular AEM5 or CQ561 to AEM61 upgrade for a large AEM assets customer in managed services, Conde Nast International. Now, these guys have a fairly large repository. At the time, it was 30 terabytes, and a fairly unique architecture where they had an author instance in EMEA and author instance in APAC that was sharing the same S3 bucket. And we had a number of challenges with the upgrade, but the one we spoke about in 2016 was how we minimized the downtime for the end users in the upgrade, predominantly by reducing the time taken for indexing after the upgrade. Now, if we did an unoptimized, unassisted upgrade, because of the nature of the customer's content, the large amount of text extractable content, the time for the indexing to complete and the environment to become available would have been days in their EMEA environment and weeks in their APAC environment. Now, that's largely due to the fact that AEM will try and download, or Oak will try and download the binaries of files it considers text extractable and pass them to Tika for text extracting as it works through the indexing. And for a customer like C&I with many terabytes of text extractable files, that is slow, especially for the APAC environment where the connectivity to S3 is slow. So the customer's expectation at the time was that we could complete such an upgrade in a weekend so the end users wouldn't notice any downtime. And I described last time how we leveraged some new Oak features at the time, which we enhanced along the way, for something called text pre-extraction that allowed you to generate a store on disk of the text extracted from binaries and use that to optimize your indexing. And we did that prior to the upgrade. We spent the entire week before that generating the pre-extraction store on the EMEA environment, and we shipped it over to APAC. So the project was a success. And it didn't need to download all these binaries, and we got the upgrade through in a weekend, but it was very manual, and it was a bit reactive. We discovered problems late in the day as we moved up to the bigger environments, and that meant that we weren't able to predict the end delivery date of the upgraded environments as accurately as we wanted to, and the customer probably felt a bit of impact with that. The date slipped once or twice. So in order to become a bit more proactive with this and to build things that are more reproducible, reusable, and scalable, it's probably obvious that better collaboration between AEM engineering and Adobe Managed Services is required to learn more about customer systems.
Right, and so the first attempt after that was that we said, OK, we need to dry run those. And since we had AMS, we have customers there, which we can ask, can we get a clone of your system and do some dry runs and do it ourselves? And this is specifically for the engineers that typically don't do these kinds of operation activities. So this was our kind of the first step in the direction of DevOps and exposing engineers to these kinds of aspects. So we started to have a dedicated amount of engineers that were supposed to go through that process, working together, collaborating with AMS. And AMS provided us with cloned production environments of real customers with the real production data, and which were picked on base of providing a lot of diversity of customers. So different modules, sites, assets, forms customers, communities customers, big customers, small customers, all kinds of things. But and having really engineers performing the upgrades and being exposed to the aspects. So because they can better translate what this means to other engineers and making sure that the aspects are addressed the right way. At the same time, AMS took the opportunity to talk with us about the automation aspects, so really the operations aspects of automation, and having an internal tool set, building up an internal tool set which allowed the CSEs, which are the ones that are guiding the customers through the process and performing the deployments on production, to have a tool set which allows them to have a fluent upgrade experience, at least in most of the scenarios, and not the really exotic setups, which we get back to in a bit. So, but this is not really enough, because this only scales to the amount of engineers that are available to perform those upgrades. And given the time and the concurrent need to implement stuff by the engineers, so working on the next release, we had the need to get more data. And this is when we started in 6.3, or during the after release of 6.3, we started to really work on an agent that allowed us to extract or do some kind of static extraction of usage data of customers. And for that one, we did poll all the AMS customers at the time and got a quite significant set of customers that agreed that we have this kind of anonymous extraction. So we get a significant sample set, could do this static analysis and extracting all the data in a way that allowed us to generate reports that engineers could use to base their decisions on. This is related, or this ended up, which you can see in the, was also mentioned in one of the talks on the first day about the sustainable upgrades, like identifying the patterns of usage of customers and what can be done. So this has two aspects. One is about data-driven decision-making. So we wanted to make sure that we only change things that are not breaking customer usages, at least as far as we can detect it based on patterns. And the other part is about providing customers insight in how they are doing and if they are implementing some patterns that are colliding with what we assume as best practice. So, but that's also not enough. Just having this kind of data allows us to get insights, but as you know, a lot of aspects can't be really extracted that way, like the amount of the size, the amount of workflow instances, huge version stores, and you name it, whatever is out there can impact that. So we also had the need to still perform those dry runs, but dry runs have the problem that we only we work on that, so we have no one fixing the application, looking into what it means to fix the application, because we don't have the access to the source code of the customer, don't have the insights. So next step is really, we got in 6.4 in touch with 10 customers, said, okay, we will do a better go-live project. So this was were beta projects that really started extremely early in the development phase, where we did iteratively try to upgrade those and work together with the system integrators or with the internal IT to work on how to get to those productive upgrades that were supposed to be live along with the GA date. So there's a time frame roughly a month after GA, all of the customers, with one exception, I think, which was more of a business decision on their side, were live at the time. So this was an active collaboration between the customer, AMS, and engineering, with the focus on repeatable and automatable upgrade processes. So really going strongly in the direction of DevOps. And yeah, for that one, Tom will take over before going into reference customers, again, looking into what kind of customers we did have there.
Thanks, Dom. So yeah, it's worth noting that we weren't just dealing with the simplest customers, and Dom highlighted that before. At one end of the spectrum, moving to 6.4 in time for the product GA date, we had our old friends Conde and Nast, who I spoke about in 2016. Huge assets customer, very specific requirements and challenges there. And at the opposite end of the spectrum, we had a customer like Telegraph Media Group, who I can see over there, hello Rachna, who had very different constraints and limitations, huge public news website that had very minimal tolerance for author downtime and very, very specific challenges about getting the upgrade completed in the minimum possible time. So very different customers, very different challenges, and different approaches required with each one. Thanks, Tom. So let's look at what happened with our old reference customer, Conde Nast International, this time round. So 2 years later, the challenge has increased a bit. Their production repository is no longer 30 terabytes, it's 100 terabytes with over 4 million assets. So you're talking about a significant volume of data here. Perhaps beyond the normal sizes that AEM engineering would be testing with upgrades and with very specific data in this case, because so much of it was text extractable. The DAM had become central to their content syndication process and magazine production, and they had over 200 authors using the system daily, so very limited downtimes possible. The success of the system means that it's been adopted all over the world, so we had a downtime window really between the end of day Friday on their Americas markets, Mexico, the US, and the beginning of the next week in their APAC markets. So that's a really relatively short amount of time to work on such huge amounts of data. So last time, the upgrade was largely a manual process, and I executed a lot of it over a weekend. I was the Adobe consulting architect on the project at the time. For the good of the customer, reducing the risk, and for the good of my marriage, we realized that we were going to have to automate this a bit more, and I would be able to delegate some of it. So although we were going to be doing an in-place upgrade, so keeping the upgrade as close to the standard as we could, as you'll see later, the optimized process involved quite a complicated sequence of steps. And some of them were going to take hours, and we wanted to make sure that they were run properly back to back. We didn't want the system to be sitting idle, waiting for someone to finish their dinner and come and check that the next thing needed to be triggered. That meant we had to also implement some validation to make sure that the previous steps had been successful. Now, this time round, because of the Tenet GA program, we were lucky enough to have early AEM engineering involvement, and that meant that we could focus on rolling back the optimization options that we came up with into the product and be a little bit more proactive than we were last time. So how did we go about this? Well, we've had a fairly simple approach, which I'd recommend to anybody. Try the hardest upgrade first, of course. Don't leave your test upgrade of your production environment until the day before you're due to go live on the new version. So we've tried an unassisted upgrade of the production 6.1 environment to 6.4, and did it behave as we expected? Well, we'll get into that later, but yes, it did. Then, by observing carefully what was going on, looking at the log files, looking at the JMX beans and the metrics available in the product, taking a lot of thread dumps, and using the AEM profiler, we were able to identify pretty carefully what the bottlenecks were, and we iterated, overcoming those bottlenecks as we went along. working with the appropriate people throughout the engineering and consulting and product teams to overcome those, and automating as we went along. Effectively, we rehearsed continuously. So after every execution, we just started another one with the latest enhancements. And we did that for a month or so. So we had done many, many rehearsals, and by the end, it was completely automated, and it was just a big button that we could press and kick off the upgrade, and we were very confident in how that would happen. So looking into the specifics a bit more, as you might imagine, as before, re-indexing on the upgrade proved to be the most time-consuming. So when you upgrade the AEM product from 6.1 to 6.4, many of the out-of-the-box index definitions change, and those changes are applied by the actual product upgrade, and that triggers re-indexing of those indexes. Now, in the larger CNI repository that we have now, over 20 terabytes of text extractable files exist, so that re-indexing would be weeks. Last time we were able to use pre-extraction, but as I said earlier, even generating the pre-extraction store took us the week leading up to the upgrade, which really inhibits our ability to rehearse and made the whole process a bit unwieldy. And we were very lucky last time that didn't cause us more problems. So this was the first bottleneck we looked at. Can this be optimized? And the answer is yes. We were very lucky to have the assistance from the Oak engineering team, and Vikas Saurabh on that team, who many of you may know and have worked with, came up with a brilliant idea, a brilliant observation, that the existing Lucene index, of course, contains all the text extracted from the binary properties in the repository already. So you can actually use that as a very efficient source for generating a new pre-extraction store with Oak. That reduced the time to generate that pre-extraction store from days, most of which were spent downloading from S3, to a couple of hours, even generating it directly on the APAC environment, and removed the need for us to generate the store in EMEA and ship it to APAC. That's become part of the product in Oak 7.3.5.3, and is something very, very generic and very useful that we'll get back to later. So even with a full pre-extraction store, so no necessity to download files from S3 and pass them to Tika in a single thread and extract the text from them slowly, iterating through and re-indexing a 250 million node repository is going to take several hours. And we only had a certain number of hours, so this looked like the next biggest bottleneck. So what could we do to avoid that? By default, this re-indexing, as I said earlier, would happen when the AEM upgrade is occurring and the index definitions get changed. So right in the middle of our allowed downtime. And we really didn't want to be sitting around twiddling our thumbs for maybe 3 or 4 hours while we iterated through the whole repository and performed re-indexing. So what could we do to optimize that? Well, Oak 1.8 has a feature called out-of-band indexing. I'm not sure whether anyone's used this. This allows you to use Oak Run to perform indexing, and you pass in the index definitions that you want to use when you do that. So we were able to extract the index definitions from AEM 6.4 and then clone the AEM 6.1 repository and use Oak Run 1.8 to effectively index that repository with the new definitions. Now, this requires some clever use of repository checkpoints. Anyone who's done a lot of work with Oak asynchronous indexing will know a little bit about how checkpoints work, and you're able to leverage those so that you insert a checkpoint index using Oak Run up to the checkpoint, and then when you merge back in the indexes, Oak knows that it needs to top them up with a catch-up between what's changed between the time you took the checkpoint or you put the checkpoint in and now. So that overcame our next bottleneck, and we ended up with a fairly tight and sophisticated process. There were a number of smaller challenges that we had, which I can discuss later, but I thought I'd focus on these really fundamental ones and how the process worked for those. So if we revisit our original objective, you remember we were trying to reduce the amount of downtime to the customer during the upgrade. So all of the techniques I've just described are about basically offloading work and heavy lifting that would normally be happening synchronously during the downtime, during the actual product upgrade, to happen earlier, while the customer's still live. So we split the upgrade into 2 distinct phases. Phase 1 occurred while the DAM was still available to end users, and we did as much as we could there. So that started off with us creating a checkpoint in the AEM 6.1 author environment, as described earlier, and then we cloned that. Now, AMS has all sorts of tooling and automation for cloning instances because we're using cloud providers. And we downloaded any existing pre-extraction store and all of our tools and libraries from S3. So we'd created this migration S3 bucket, which was going to be our kind of back end for the migration and assist us with sharing artifacts between the environments. This was very useful. We created one in each of the regions that the author servers exist, and it just gave us a performant way to move things between clones. So we've got the existing store and all of our tools and scripts and libraries down on the clone. We then update the pre-extraction store from the Lucene index using Oakrun and the work that Vikas Sarab did for us early in the project. And we uploaded the generated pre-extraction store to S3. Then we used the AEM64 index definitions to perform out-of-band indexing on the clone as well. So we then have indexes with the AEM64 definitions sitting on the clone up to the checkpoint. And the checkpoint, if you remember, still exists in the real environment as well. And we uploaded that generated index data to S3. That was quite a lot. You know, the generated indexes here were maybe 150, 200 gigabytes worth of indexes, all of the text in all of those assets. Great. So at that point, we can complete phase one and wipe out our clone. Now we have to move to the actual author downtime. So we begin phase two. The DAM becomes unavailable to the end users. This is our upgrade window, and this is what we're trying to keep as short as possible. So what can we do? Well, we take another clone, and the clone still has the checkpoint in, if you remember. And we download the pre-extraction store and the generated index. At this stage, the pre-extraction store isn't all that useful for the upgrade, but it's a good thing to have on the environment anyway in case the customer in the future needs to re-index or anything else. And we leave that configured, as we do with lots of assets customers in AMS. So we place the index in the AEM repository folder, and we use Oakrun to do the repository migration that's a standard part of any AEM 6.1 to 6.4 upgrade. At this point, we start AEM, which performs the upgrade. Now, what works so well here is that the indexes that we did with the out-of-band indexing are merged in before the upgrade starts. And they're merged in with both the index data and the index definitions. So that all gets added to the repository. There's a catch-up between the point of the checkpoint and now. And we can release the checkpoint. So the indexes are now 6.4 indexes with caught right up to now, and then the product upgrade code starts upgrading. At that point, it upgrades the index definitions to match the 6.4 index definitions, but they already matched them anyway, so there were no changes and no re-indexing was triggered. So we'd overcome our big bottleneck. We were then able to make the environment again available to the end users to do some smoke testing and cut over. And that phase two end-to-end there, I think we had that done by about Saturday lunchtime on our weekend. So we were able to give the customer a clear day and a half to smoke test and decide that they were comfortable cutting over to AEM 6.4. So by optimizing in this way, we came in significantly within the boundaries that we put on ourselves. So what can we reuse in an approach like this? Well, the approach for generating the pre-extraction store from the Lucene index is extremely generic and easy to use. And that's something that I've manually applied to other AMS assets, customer upgrades, and even customers who've needed to re-index, but is likely to become baked into our actual AMS upgrade automation, I think, fairly soon as well. And it's a really, really excellent optimization that makes a huge difference for these larger assets customers.
So, yeah, but the question is, what is slope? And like this is, if you can imagine, this is something you can't have in the in-place upgrade because there is a lot affecting the topology. So most of the improvements are in the tooling in there. So to explore what is coming next, one is for the AMS offering, and there is something which is currently being rolled out to some of the AMS customers. Which is the Adobe Cloud Manager, which allows to allows us to provide a pipeline, a continuous integration, a continuous deployment pipeline as a kind of a self-service tool, which also in the future will integrate with our engineering pipeline. So therefore, whatever we produce as new release is getting fed in there, automatically tested, and can be fairly easily being deployed. And this also allows us to hook in all these kinds of tooling into a default process. So for you, this means, sorry, there is still some stuff to do to set up the process. We provide you, you have these slides to see the process as it was used internally. The automation is something you still currently have to set up yourself. But I know there is quite a lot of tools for like the Ansible and the Puppet and Chef things are out there, which allow you to implement all of that quite easily. Also, you can look into the talk that we had last year about effectively not requiring these kinds of cloning processes. We're looking into the blue-green deployments. So for these kinds of Docker-based setups or containerized setups, we are looking into how we can split off the application part and basically reuse the existing repository. But this, again, does not save you from the cases where you have these kinds of re-indexing challenges, because if a new release requires new indexes, this is something happening in the immutable space, so you have a change in the content and not in the application head. So we are currently working on rethinking the deployment processes and how to effectively install also packages or application packages. But the most active one, or where you currently see quite a lot happening, is about rethinking how indexing actually works. So some of the improvements that we have here are currently done by external tooling, so you require Oak Run to perform that. Some of that is supposed to be changed, and if you just look into the recent activities of Oak issues, you will see that Thomas Müller and Vikas are collaborating quite actively on solving this challenge, how index updates need to happen within an instance. So probably this kind of extra tooling is eventually no longer be necessary and works out of the box. So what does this mean to you? To recap on what you can learn out of that. So what are the takeaways that we have? We want you to learn the same lesson that we had to learn is you should automate as soon as possible. Start with automation right when the project starts. Do a plain upgrade with the out-of-the-box functionality and see where you have bottlenecks and start to script that down. You shouldn't write the same commands over and over, but really the easiest way is just write a shell script. Even if you have no automation being set up, write a shell script where you execute that again. And we had to do that in a particular case for Sinai. We had to do that because we had something which the automation of AMS was not designed for, which was this cross-region coordination. So we had to have some extra shell scripts which did take over some parts of the stuff that had to be done manually before. You should also measure continuously. So establish a baseline, and whenever you do these kinds of tunings, you want to make sure that you're not shifting one bottleneck to the other without noticing. We have seen more than one upgrade project where they noticed that they did attempt to do an upgrade, the productive upgrade, it failed. They fixed that and tested exactly this aspect, but then they shifted the bottleneck to another point, and they basically did not execute this fully end-to-end. And this is one of the key things for Sinai was we did automate it really end-to-end and did reiterate over the complete end-to-end process over and over. Also, you should have a look into what kind of tooling, like these changes, the latest changes in Oak 1.8 and to Oak Run. This is the one side, and also what we're doing in Sling. Everything that you can see that we do as tweaks to those processes, like I would say 90% of that is visible in a public space. It's just about these kinds of tooling like Cloud Managed that are the plumbing code that is specific to our AMS setup. So yeah, watch out for those ones. And last but not least, please get active and contribute. So we are seeing the ones that we're seeing in the test runs that we are doing. You have other customers, you have other footprints, you see other bottlenecks. And as the majority of our stack is open source, you can contribute. You can discuss that, you can inform us, but you also can, if you are in the area, can debug this stuff and start to contribute through Git pull requests or whatever you want. We are really looking forward to see what you can share with us so we can tweak the experience for you. And I guess that's it. Thank you. Do we have any questions? There is a question in the back.
Hi, Dominik. Hi, Tom. Thank you for the presentation. It's really a good thing to hear such stories. Do you plan to put your scripts or the approach you used in detail somewhere public so people can actually get hold of that scripting and maybe even the parameterization of Oak Run to start learning from it and maybe imitating your approach?
We could look at that, certainly. Yeah, some things at the time we used them weren't available in public builds of Oak, but they probably would be now. So maybe I'll try and do a blog post somewhere about that and put the approach and some of the scripting, the bits that aren't dependent on other bits of managed services command and control. I'll try and put them somewhere so people can have a look.